Presentation is on tangent functions. Tangent function is defined as the tangent of an angle is the opposite side of a right triangle divided by the adjacent side of the right triangle. To find the tangent of 30 degrees, the first thing we're going to do is we're going to draw our reference triangle. And then after that, we're going to set up the ratio of the opposite side over the adjacent side. The opposite of 30 degrees is 1/2. The adjacent to 30 degrees is radical 3/2. We're going to multiply by the reciprocal of the denominator in order to simplify this fraction. After we simplify, we need to check to make sure we don't have any radicals in the denominator. Sometimes you will have to rationalize the denominator to get rid of the radical. To get rid of this radical, we're going to multiply by radical 3 over radical 3. So the tangent of 30 degrees simplifies to radical 3 over 3. Find the tangent of 5 pi over 4 radians. 5 pi over 4 radians is in the third quadrant and has a reference angle of 45 degrees. Anytime you have a radians that is divided by 4, it's going to have a reference angle of 45 degrees. When we draw our reference triangle, both the x and the y height of the triangles are going to be negative since we're in the third quadrant. So then the ratio of the opposite over the adjacent is going to be negative radical 2/2 divided by negative radical 2/2, which is equal to 1. So the tangent of 5 pi over 4 equals 1. The tangent of negative 60 degrees, we're going to draw our reference triangle. This time we're going to be in the fourth quadrant since we are rotating 60 degrees in the clockwise direction. So that means the x value is going to be positive 1/2 and the y value is going to be negative radical 3/2. I'm going to multiply the reciprocal of the denominator in order to simplify the fraction, and then we get the tangent of negative 60 degrees is equal to negative radical 3. This one doesn't need to be rationalized since we don't have a denominator. A tangent line touches a function only once. The line x equals 1 is a tangent to the function, tangent to the unit circle. The y-coordinate on the x equals 1 will give you tangent value for any value of tangent of theta. The value of tangent of theta will get closer and closer to pi over 2, but will never reach it. Tangent values of the function can also be calculated using the ratio of sine to cosine. So although the tangent of an angle is equal to the opposite over the adjacent, it is also equal to the sine of the same angle divided by the cosine of the same angle. So to find the tangent of 0, we have sine of 0 over cosine of 0, which is going to be 0 over 1, which equals 0. The tangent of pi over 4 is going to be the sine of pi over 4 divided by the cosine of pi over 4, so that's going to be equal to positive 1. The tangent of negative pi over 4, we're in the fourth quadrant here, so the sine is going to be negative radical 2/2, and the cosine is going to be positive radical 2/2, and that's going to be equal to negative 1. We will have undefined values for tangent functions. For example, the tangent of pi over 2 is equal to the sine of pi over 2 over the cosine of pi over 2, which is equal to 1 over 0. Whenever we have a 0 in the denominator, we're going to be undefined. So there are going to be several values of tangent functions that are undefined. To create the graph of the tangent function, we are going to use the information we found on the previous page to create a graph. First, we're going to start with our asymptotes. We have asymptotes in tangent functions because that's where the function is undefined. So we're going to put asymptotes at negative pi over 2 and positive pi over 2. We're going to use the other tangent functions to form coordinate points of negative pi over 4, negative 1, 0, 0, and pi over 4, 1. We're plotting those points and we're going to connect them to form a curve. Your curve gets closer and closer to the asymptotes but never crosses. We're going to repeat the pattern to find the next cycle. So 3 pi over 4 is comma negative 1, pi comma 0, 5 pi over 4 comma 1. Properties of tangent functions. So if we have the general form y equals a tangent of b theta, a is going to be your amplitude and b is going to be the number of cycles between 0 and pi. So your cycle is going to start at negative pi over 2b and it's going to go to positive pi over 2b. The length of the period is going to be pi divided by b. If we have a positive a value, it's going to be an increasing function with coordinate points at negative pi over 4b, comma negative a, and pi over 4b, comma a. And then if the a value is negative, we're going to have a decreasing function. The location of one of the asymptotes is where the cycle starts. The next asymptote can be found by adding the period to the previous asymptote. So the length between asymptotes is going to be the same thing as the period length. In a graph, y equals negative tangent pi times theta. So the amplitude is going to relate to a equals negative 1. We're going to have a decreasing function since a is negative. The cycle, we're going to use the cycle formula and we're going to plug in pi for b. Simplify, our cycle is in between negative 1/2 and positive 1/2. The period is pi over b. When we plug in our b value of pi, we're going to get a period of equal to 1. The first asymptote is going to be where the cycle starts. The next asymptote, you're going to add the period, so negative 1/2 plus 1 is going to give our second asymptote of 1/2. To find the next asymptote, we add 1 again, so 1 plus 1/2 equals 3 over 2. We need 3 asymptotes because we need one more asymptote than the number of cycles we are graphing since a cycle begins and ends with an asymptote. The first thing we plot is going to be our asymptotes. Some graphing tips are to scale your graph according to half of the cycle. So since our cycle is negative 1/2 to positive 1/2, we're going to scale it by 1/4. We're going to plot our points and then connect the curve. We have a decreasing function since the a value is negative, and be sure to make sure that your tangent function never crosses the asymptote. Here are the tangent practice problems. Try to complete these on your own and then show them to Ms. G when you are finished.